Use the method of cylindrical shells to find the volume generated by rotating the region bounded by the given curves about the specified axis, and then sketch the region and a typical shell. So we have the function y equals x squared, which is graphed here, and then we have y equals 2 minus x squared, which is the one that's in blue here, and then we have it about x equals 1. So we're rotating it by the region bounded by that vertical line of x equals 1. Okay, so now we need to look at the two functions. Okay, so if you take a look at these two functions, you have the height of this blue function, and then there's the height of the red function. And so we want to find the differences between those two. Okay, so at that point where you see at that graph, we want to create a cylindrical shell. And the reason why we're doing that is because we're rotating it around the vertical line of x equals 1. So what we're going to do is we're going to create a cylindrical shell, okay, at these 2 points. So there's our first cylindrical shell. Now we can create many, many more of those, but there is our cylindrical shell. Now, again, like I said, we can create many more, cylindrical shells, right? And we would stack them all up because then we want to find the sum of them all. But I want to delete that so you can see that you can create more cylindrical shells. So now in order to find the volume, we're going to integrate this by finding the volume, and that's going to equal whatever our lower and upper bounds are of a of x dx. And that's because we're revolving it. In this case here, you can see that it's at the vertical line x equals 1, but we're looking at in terms of x because these functions are also in terms of x. So another reason why it's in terms of x is that if you look at this cylinder, right, if we, kind of just opened it up, completely, you're going to get this thin piece of cylinder. So when we open that up, this is the figure that we're going to get. And so this is on we want to find the area of that. And so as we keep moving on the x-axis, this is like a thin piece of that cylinder, and we have more and more. So as we're moving on the x-axis, this is what we're going to get, which is y is in terms of x. Okay, so now what we want to do is we want to be able to find the bounds of this integration. So the bounds are going to be where they intersect, which is here and here, right? So we can take a look at the points on the graph, or we can solve to find out what are those points. So over here, if we want to find those bounds, we're going to set this x squared, so it's y equals y, and we know that the one function of y is x squared, and the other one is 2 minus x squared. Okay, so if we bring this on the other side, to the left side, we're going to get 2x squared minus 2, which is equal to 0. If we factor out a 2, we get x squared minus 1, which is equal to 0. We get 2 times x plus 1 times x minus 1 equals 0. And therefore, if we divide both sides by 2, we have x plus 1 times x minus 1 equals 0. So x is going to equal negative 1, and x is going to equal positive 1. So now we know our lower bound is negative 1, and our upper bound is going to be positive 1. So now going back to this cylinder, we saw the cylinder was laid out in this form if we just opened it up. And so what we want to be able to do is we want to be able to find this right here, which is that height. And so in order to get that height, that is going to be this height here that we're looking at when we open that up. And they're thin. It's a very thin piece. And so what we want to do is we want to take the height of this blue function and then subtract the height of this red function. So you can see here that there is, in order to get this piece, we have to subtract the height of the blue minus the height of the red, so for us to get this piece here. So what we're going to do is we're going to take that function, which is 2 minus x squared, and then we're going to subtract the red function, which is x squared. Okay, now that we have that, now we want to take a look at the base, which is this cylinder. Okay, so if we take a look at that cylinder, we want to be able to find the circumference of that cylinder. So that means that we're looking for this right here. And now when we talk about the circumference is equal to 2 pi r. But we don't want this in terms of r. So our goal is to find this radius in terms of x. So if I take a look at this circle down here, which is the base, okay, you can see that the vertical line is at x equals 1. And so then, because I'm going in this direction towards this function, that means that radius is now going to be represented by 1 minus x, because you're taking this 1 and then you're subtracting x. So therefore, this radius now becomes 2 pi times 1 minus x. So now let's clean this up. So this here, which is the width of this particular rectangle, when we fold out that cylindrical shell, if we combine like terms, this becomes 2 minus 2x squared, okay, which is this. And then we can see that this piece here, which is the base, is now 2 pi minus 1x. Okay, so what does that tell us? Well, that tells us the following. If we want to find the area of this rectangle, well, that's going to equal the base times the height. So a of x is going to equal the base, which is 2 pi times 1 minus x times 2 minus 2x squared. So now let's go ahead and multiply this out. So if we multiply that out, we're going to get 2 pi times, foiling this out, 1 times 2 is 2, and then that's minus 2x squared times 1 is minus 2x squared, minus x is minus 2x, and then this is positive 2x cubed. Okay, and then what we can do is, now let's just clean this up a little bit. Well, we can factor out a 2. So if we factor out a 2 and multiply it by that 2 pi, that's going to give us 4 pi. And then we're just going to reorder it in descending order. So we have, let's see here, we have 1. We'll just factor out, so that's 1. And then we have minus x, so I'm just bringing this one over, and then minus x squared, and then plus x cubed. So now we know what our function is, and now we're ready to integrate. So we're going to plug it into this formula. So now we know in step number 3, the volume is going to equal, if we factor out the constant, it's going to be 4 pi. We know it's going to go from negative 1 to 1 of the function 1 minus x squared plus x cubed dx. Okay, so now let's find the antiderivative. So we have 4 pi. The antiderivative of 1 is going to give us x, minus the antiderivative of x is going to be 1/2 x squared, minus the antiderivative of x squared is 1/3 x cubed, and then the antiderivative of x cubed is plus 1/4 x to the 4th. And then we're going to evaluate that from negative 1 to 1. So now let's go ahead and then plug in and evaluate. So the first one, when we plug in 1, we're going to get 1 minus 1/2 times 1 squared, which is 1/2, minus 1/3 times 1 cubed, which is 1, plus 1/4 times 1 to the 4th, which is 1/4. Okay, minus. Now negative 1, so we have negative 1, and then minus. Well, negative 1 squared is positive 1, so that's minus 1/2. And then that's a minus. Well, negative 1 cubed is negative 1, so negative 1 times minus 1/3 is going to give us plus 1/3. And then plus 1/4 times negative 1 to the 4th, which is going to give us plus 1/4. Okay, so now let's just go ahead and distribute that sign and then combine like terms or find a common denominator. So we'll go ahead and do that. So we have 1 minus 1/2 minus 1/3 plus 1/4. And then if we distribute, we get plus 1 plus 1/2 minus 1/3 minus 1/4. So are there any things that we can eliminate there? We can eliminate the minus 1/2 and a plus 1/2, and then we can eliminate the 1/4 and the minus 1/4. And so therefore, we have 4 pi, 1 plus 1 is 2, and that's minus 2/3. So that's going to be 6/3 minus 2/3. So 4 pi times 4/3 is going to give us a volume of 16 pi/3.